All right, gotta record this before my computer dies. I'm at 11%. Hi, everyone. So today we're going to be talking about sound waves, and I'm going to talk about basically how different instruments, types of instruments, create different sound waves that you hear and interpret with your brain. Okay, so the source of all sound waves is a vibration. Now, it could be a vibration of a guitar string, like you see in this picture right here. It also could just be the vibration of the particles of air. So we learned last week that there's two different types of waves. There's longitudinal waves and there's transverse waves, okay? When you have a guitar, or in my case, a ukulele, when I pluck this string, it vibrates back and forth, creating a transverse wave. Remember, transverse wave, the particles move perpendicular to the actual propagation of the wave. So it looks like this, okay? Now, on the other hand, a sound wave that you actually hear is what we call a longitudinal wave. And remember, longitudinal waves have different areas of compression of particles and what we called rarefaction, where those particles are spread apart. So what's happening here is that when that guitar string is plucked in a piano, a guitar, a violin, a ukulele, the vibration of the strings create the sound. So what's happening is those strings vibrate back and forth. They disturb the air molecules around them, creating a sound wave, okay? So the actual string is a transverse wave, but the sound wave that the string creates is actually a longitudinal wave, okay? So that vibration sends a disturbance through the surrounding air, looks like this, and that is our longitudinal sound wave. Now, I want to show you just a short video of these guitar strings vibrating like this, and then we'll talk about how guitars make different sounds. So we have... You can actually see the waves, standing waves that are made on these guitar strings. You can do this if you have a guitar, you just stick your ice on the guitar. Cool. Pretty cool. Okay, so string instruments like a guitar, a ukulele, etc., etc. There's three ways to change frequency on a string instrument. Number one is that we would move our fingers to different frets on the string. So if I played this top string, if I shortened the string and I pushed down right here, I get a higher pitch sound. So pitch is the word that we use to describe frequency, okay? So a higher pitch, higher frequency, okay? So a shorter string, you get a higher frequency and a higher pitch. Longer string, lower frequency, lower pitch. Another way is to either tighten or loosen the tuning knobs at the top. So if I tighten or loosen this knob, there I'm tightening it, and you can hear that the pitch is getting higher, and then I'll loosen it, and the pitch is getting lower, okay? So the higher the tension, the tighter the string, the higher the frequency, the higher the pitch. And last but not least, another way that frequency is different on these guitar strings is the larger the strings are, they're going to vibrate slower and therefore have lower frequencies. It's kind of hard to see in the video here, but this string is larger in width than this string. And therefore this string has a higher frequency and therefore a higher pitch. All right, it was kind of easier to see on that video that I just played you guys because the string on the top was the thickest and it was vibrating the slowest and had the lowest pitch. All right, let's talk about wind instruments. So these are a bunch of different types of wind instruments. We have a piccolo on the far left. It's a very small wind instrument. A recorder, if you guys remember those from elementary school, on the far right. And then one in from the right, that's called a bassoon. I don't know if you know what a bassoon is, but it's a very large wind instrument. My husband actually used to play the bassoon when he was in middle school, I think. So the bassoon, you probably already know this, especially if you're a musician. It's very large and it plays very low frequency sounds. So that those sounds that it plays are much, much lower. Whereas the piccolo and the flute, right, those are smaller instruments, are going to play higher pitch sounds, okay? And so the smaller and shorter the instrument, the higher the pitch, the longer or larger the instrument, the lower the pitch. And I can actually demonstrate this with different sizes of water bottles. These are two mineral carbonated waters. I'm like a connoisseur of sparkling water. I love it so much. So this is a Pellegrino bottle. It's larger than the Topo Chico bottle. So if I blow into these over the top, it's a low pitch sound. That's a little bit of a higher pitch sound, okay, because this bottle is smaller. Now, if I filled this bottle with water a little bit, what's going to happen here is I am decreasing the amount of air that sound wave is able to create a standing wave in. So because I'm decreasing the amount of air, again, I'm shortening the place where the object can make a wave. So the shorter it is, the higher the pitch. So this should be a higher pitch sound because it's much shorter. And you can hear that the pitch of this is much, much higher. Okay, so lower pitch, higher pitch. And you can actually also tap on these and hear the different pitches as well. Or if you had water glasses, you can like over the top, you know how you lick your finger and in that scene in Miss Congeniality, you guys know what I'm talking about? Maybe if you don't, look up Miss Congeniality water goblet song or something. I don't know. So again, if you have a trombone player can then change the pitch by moving the arm of that trombone. So a longer arm means a lower pitch. Of course, this is kind of simplifying this. I do know that you can play different notes on these instruments as well by changing the orientation of your mouth and things like that. So this is an oversimplification, but it still holds also. All right, so this is kind of what a wave looks like in one of those wind instruments. So just like we learned about standing waves last week on transverse waves, standing waves are also created inside a musical instrument with a longitudinal wave. So not only are standing waves made by transverse waves, they can also be made with longitudinal waves. I want to show you guys a video that's really cool. This is called Rubin's tube. And what happens here, they're going to explain it as well, but there's a tube and they poke holes at the top and then run gas through it. It's very safe. And then light the gas on fire. And then don't try this at home, please. And then they play different frequency sounds through that tube and it creates different standing waves, which then you can see with the fire. I've always wanted to do this in my classroom, but it's a little bit too dangerous.
The fifth experiment in the cymatics music video is the Rubin's tube.
So the Rubin's tube is my personal favorite experiment.
Okay, just tell us how it works. Okay, so we've got our propane. It's going to flow in here. There's a line of holes here. One end is blocked off, the other end is a piece of latex on it. And we're going to play a sound very loudly onto the latex. It's going to form standing waves of gas, and it's going to come out the holes at different heights depending on the frequency of the waves. Plan. Here we go. Oh, that's good. That's good. That's a nice, safe play.
It looks like a graphic equalizer, just made out of fire, which is really visually exciting. It looks like a Gothic organ or something like that.
So pretty cool, right? So that's a little bit about just sound waves in general. Next week, we have our last week, and you guys actually have a project in which you will make your own instrument. So that's why I kind of wanted to go over a little bit about how different frequency sounds are made with different instruments. So look forward to that next week. It'll be really fun. I'm excited. So I hope everything is good with you guys. I hope you learned something today, and I will see you soon.